Now, the next practice that we do with domains and ranges, although it's in the textbook, so you can go to Theta and do some of this work, but the piecewise functions and writing the domains or range restrictions, really, really, really important practice for the internal. I mean, incredibly important. If you can do this, then you're well placed for the internal. The thing that is not a big functionality of this is the whole closed and open dot, but we're going to deal with the closed and open dot because we've already done the stuff about that. So we know that when we have an open dot, that means that it's not equal to, that doesn't include that. And when it has a closed dot, it does mean that it's equal to. So we want to basically create the equations for these graphs, which we should be able to do, even though we've only got a portion of them, and then come up with the rules for each one of these pieces. So this is a piecewise function, A is a piecewise function, B is a piecewise function. So let's take a look. We're going to go to Desmos, and we're going to have a little play on how we can sort of make this piecewise function, because making the piecewise function is actually extremely useful practice. So if I want to replicate this, I need to know that this is a parabola. I'm going to assume it's a parabola. Most of all, these are parabolas or straight lines at this point. So let's just say we're going to use a parabola. And in this particular parabola, it goes through 0, 0. So I'm going to assume, I have to do a little bit of an assumption here, that this is sort of the parent function of y is equal to x squared, okay? So I'm going to just assume that there's no stretch on this because we're at 1 and -1. We're not going to do much in the way of stretch. So let's just assume that that's the first piecewise graph, the first section of the piecewise graph on the left-hand side here, okay? Now, how do we restrict, let's just talk about the domain in this case. How do we restrict the domain for this section so that we can get it to look like that? So we're going to use these brackets in Desmos. If you are doing this not in Desmos and doing it by hand, then you don't need these brackets, you don't know anything about these brackets, but we're going to be using Desmos, so let's just get used to that. We have an open dot, which means that this graph is going to be less, x is going to be less than, but not equal to 0. Right? So we don't want that equal to sign, we just want less than. And then when we go over to this graph, you see that it does this whole kind of open dot thing, and it goes 0 and undefined, because in fact, we are not going all the way to 0, 0. We're going basically an open dot and less than 0. So Desmos will actually sort of show you what that does. And although this graph shows more than the -1 to 1. I mean, if I wanted to change this so that it went to, on the x-axis, it only did, or on the y-axis, sorry, it only did -1 to 1, right? And this only did -1 to 1. This is not really necessary, but I'm just going to show you. So we end up kind of getting a similar thing to what they're drawing there, right? So yeah, sort of looks like that, right? And the thing is that it goes on forever in this direction. There's no dot on the far right or far left of this graph. There's no dot. So this graph, although it doesn't show, would go forever that way, but it's like an open dot here. So that's the first part, okay? Now, we need the second part. What is the second part? Well, that's an upside down graph. So it's going to be y is equal to negative x squared, but equal to negative. But that's not going to be sufficient because look where the vertex is. The vertex is at 0, 1. So this is going to be, there's not going to be anything applied to the x because it hasn't shifted right or left, but it's going to be up 1. So it's going to be plus 1. See how that works? So now we've got that part of the graph, but we've got the whole graph. We don't want the whole graph, but it only goes to this point here, and we don't get the rest of it. So how do we restrict that? Well, we'll go to our little curly brackets, and we'll restrict this. So It does have a dot, a closed dot, so it's going to be x is going to be greater than or equal to 0. Yeah, you see, so that's going to be a closed dot. That includes 0, 1. This one doesn't include 0, 0. And so that's the kind of situation that we have, although it may show you the dot. Oh, now it's going to show me the dot. That's interesting. Oh well. We get the idea here of what's going on and how we restrict this. Again, there's no dot past the far right, so that means this graph is going to keep going. There's no restrictions on the range of any kind, because that's going to keep on going down and that's going to keep on going up. But there is definitely a restriction on the where this graph can sort of, where it begins and ends in various places, right? There are restrictions on the x values, on the domain of these graphs. So this restriction is this. And so if we go to write that, you'll notice that in theta, they actually write this. I can just make that, do that. When they write this, no, I can't. Oh, I guess I can. They use, I think I've got it up here somewhere. Do I have? No, I don't. They use kind of a long, curly line, and then they put the two functions and then the rule. So the first function is y is equal to x squared, and then they put the rule, which is x is less than 0. And then they go and they go with the other function, which is negative x squared plus 1, and then they give the rule, which is x is greater than or equal to 0. So they kind of do this, give the rule, give the function, give the function, give the rule, and that's kind of how they write it. And so it becomes quite important to be able to do this. I'm going to allow you to try the next one, come up with the equation and the restrictions. And in fact, you'll see that there are actually 3 functions in this one: the parabola, the straight horizontal line, and then another straight line here. So there's actually 3 functions. So give it a go. This is very, very good practice.